Hey, I'm Barry Mitchell, and welcome to Simply Science. We're at Manhattan Aquariums on West 37th Street, and a little later, we'll tell you about some tiny goldfish causing big headaches. But first, there are scientists who theorize we can fight global warming by deflecting the sun's rays. Here's Donna Hanover.
In the last decade, we've had 9 of the hottest years in human history. So scientists are deadly serious about doing something to stop global warming. Some of their ideas verge a little bit on the science fiction. Like, what if you could reduce the warming on Earth by using mirrors to reflect some of the sun's rays back into space? CUNY professor Peter Groffman is part of the Climate Intervention Biology Working Group. They are scientists from around the country looking at the question.
There have been ideas of using mirrors, in particular to put giant mirrors in space to reflect the sun's energy back to space, which is very appealing to mirror manufacturers, but is not super realistic. The origin of the idea comes from studying volcanic eruptions. They shoot tremendous amounts of these tiny sulfur aerosols into the stratosphere, and you inject those into the atmosphere, and they're like tiny, tiny, tiny mirrors that reflect the sun's rays back to space, and they cool the climate.
This famously happened in 1815 when Mount Tambora in Indonesia erupted, causing 1816 to be the year without a summer, ruining crops in Europe and North America and causing snow in New England in June.
More recently, in 1991, there was a big volcanic eruption, and the rate of global warming slowed quite a bit.
That was Mount Pinatubo in the Philippines.
And so there's this idea, and so scientists said, well, if volcanoes can do it, maybe we can do it. We can do the same thing. So there's the idea that we can load airplanes up with sulfate aerosols, just like the ones that come out of volcanoes, fly up into the stratosphere, and add a layer of sulfate aerosols to reflect energy back to space.
What would be the potential downside of throwing this sulfate aerosol up into the high atmosphere?
In the US and in Europe over the last 50 years or so, we've spent a lot of time struggling with acid rain, which is caused by sulfur. Sulfur, we burn coal, and there's sulfur in the coal and it goes into the atmosphere. So a lot of people are like, we just spent 50 years getting the sulfur out of the atmosphere, you're gonna put it back now? And there's been some good analysis of that the amount of sulfur that they're talking about is really not enough to cause us an acid rain problem.
Another possible downside is an increase in ultraviolet radiation that may worsen problems like skin cancer.
And the sulfate aerosol particles make it kind of a hazy day, so we get more diffuse sunlight. It allows more ultraviolet radiation, damaging ultraviolet radiation through. So there's concerns about that.
Professor Groffman says before we consider reflecting the sun back, we need to remember that the main cause of global warming, the carbon and gases we've put into our atmosphere, causing a greenhouse roof effect that holds in heat, is not just happening on summer days.
So nighttime temperatures have risen much more than daytime temperatures, and winter temperatures have risen much more than summer temperatures. And a lot of the ecological effects of climate change are coming from the change in the winter and the change at night, and solar radiation management doesn't do anything about that.
Professor Groffman says it would be a big mistake to reflect the sun back without also reducing carbon in the atmosphere. One reason? If we cool temperatures, trees will not grab and store and protect us from as much of the carbon as they currently do, which could shoot warming right back up. And trees could hold less moisture, increasing floods. Also, it could change whole ecosystems, with animal species showing up where they've never been before, bringing destruction and disease.
From a straight scientific point of view, that the uncertainties and the possible downsides, I would argue, are too high, that we should not go down this route. The scientific consensus overwhelmingly is we should solve the cause of the problem. We should get the carbon dioxide out of the atmosphere. We should stop emitting carbon dioxide into the atmosphere. And we're going down that road. I'm an optimistic person. I think in 2050 this discussion is going to be very, very different, and our economy is going to be decarbonized, and we're going to be well on the way to healing our atmosphere and healing our planet.
I'm Donna Hanover for Simply Science.
Think global, eat local. Carol Ann Riddell shows how community gardens and the high school's hydroponic farm are models for providing New Yorkers with nutritious food. Okay, everyone. Old MacDonald had a hydroponic farm. Let's hear it. Very good, especially you, Mr. Limpet.
Nestled in the South Bronx, an oasis of green, bursting with fresh produce.
We have kale, we have collards, we have tomatoes, we have peppers, we have some squash going. We have chickens and they lay lots of eggs.
Brook Park is one of the city's many community gardens, once a concrete heap, now an environmental treasure that feeds local families. Even rodents are handled naturally. Raymond Figueroa heads the New York City Community Garden Coalition.
We also at this community garden have localized energy production. We also have localized water catchment systems. We harvest rainwater and water our plants. Community gardens are really ecological centers, ecological hubs of resilience.
Alexis Andaman, a senior attorney with Earth Justice, says community gardens are a vital part of battling climate change.
Because of a phenomenon known as the urban heat island effect, densely urban areas tend to be much hotter than surrounding areas. Community gardens help to counteract that effect because they provide shade, and through a process known as evapotranspiration, water travels from a plant's roots to its leaves and evaporates and gives off a cooling effect.
Because community gardens and development projects can end up as competing priorities, Earth Justice is petitioning the city to secure additional protections. The Parks Department told us they're reviewing the recommendations. In the meantime, community garden advocates say climate change and extreme weather have made these spaces more critical than ever.
Because gardens tend to have pervious paving, they have soil, water can travel into the soil in gardens instead of flooding on city streets.
Beyond the environmental benefits, the ability to grow fresh food can have a huge impact on communities, especially those struggling with poverty, hunger, and a lack of high-quality nutrition.
What we're really focused on as community farmers is really getting very, very freshly harvested nutritious food into the families.
On the west side of Manhattan, a similar goal, a different approach.
We grow a lot of leafy greens.
This is not your typical high school cafeteria. At the Martin Luther King Jr. Educational Campus, students can see their food as it grows. A hydroponic farm sits right inside, built as part of a program through Teens for Food Justice. Catherine Saul is the CEO and co-founder.
So this farm can generate just shy of 10,000 pounds of produce per year, which is a huge amount of produce to be growing in a school. Hydroponic farming is very efficient in terms of its savings of water. We use about 10% of the amount of water that you would need to grow a single plant.
Teens for Food Justice will have hydroponic farms at 5 New York City campuses serving 18 schools this fall. The mission to nourish minds, bodies, and communities, teaching teens to build and run hydroponic systems that grow fresh, local produce for neighborhoods that need it.
Historically, communities of color have been deprived the opportunity to receive quality produce. What sustainable agriculture like this allows for are for those communities to actually grow that food themselves.
So how does a hydroponic system work?
At the bottom of every hydroponic system, there will be a reservoir that's filled with water that's constantly recirculating and getting pumped to the top of the system and then filtering down throughout. So that's what we're getting at when we say that there's 90% water savings.
What we eat and how we grow it, all food for thought when it comes to protecting our planet. I'm Carol Ann Riddell for Simply Science.
Environmental gentrification is a fancy term for cleaning up blighted neighborhoods. But is it always a good thing? A Queens College professor explains how redevelopment projects often just displace residents and shift pollution to poorer neighborhoods.
We've been sort of sold this idea that environmental sustainability, urban sustainability is a win-win because we can have economic development and ecological sustainability, and we don't have to sacrifice one for the other. The book book is called The Sustainability Myth, Environmental Gentrification and the Politics of Justice. And it's about the process of trying to achieve sustainability in a real estate-driven era. Environmental gentrification is what I call environmental amenities. So environmental improvements like new parks or greenways, things that are considered ecologically friendly, but they usually accompany high-end redevelopment. So it's not that one causes the other, but they kind of go together, they're synergistic. The High Line is a very famous example, of course. Brooklyn Bridge Park is another example where developers got some kind of perks and givebacks for helping to fund that park through fees that they're charging to condo owners. Most people think about Staten Island as being kind of suburban. On the North Shore, it's much more like other parts of New York City in terms of the diversity of populations. There's a lot of immigrant populations living there, much more urban, and also very industrial. It has a long industrial history. So what I found there was that there was this 5-mile strip of industrial properties lining the waterfront, and then there's like a 2-lane road, and then there's residential neighborhoods. So they're very close to all that industrial stuff. It's just like one industrial facility after another, all right on the waterfront. I was really shocked when I first went there to see all of the legacy contaminants and all of the things that people are dealing with. So it's an area that's really suffering a lot in terms of environmental quality. A lot of studies of gentrification focus on the gentrifying neighborhoods. But what I realized is that nobody's looking at what happens to non-gentrifying neighborhoods as this is going on. And I found that there's a very direct relationship. If you're creating so-called sustainable waterfronts in parts of the city, then what happens is they're no longer places where you would put industrial uses because now people are paying a lot of money to live there. So that stuff gets clustered into non-gentrifying waterfronts, which are already burdened by unwanted land uses. So the greening of certain waterfronts that are designated for high-end redevelopment led to the browning of other waterfronts not designated for redevelopment, like on the North Shore. In this book, I trace the fact that communities of color are much more likely to live near industrial facilities. As areas begin to gentrify and environmental improvements are installed, they also whiten, so that the communities of color are priced out of the neighborhood, then they have to go to other neighborhoods where there are a lot of industrial facilities. And so this problem of environmental disparities gets reproduced. I'm a big critic of gentrification, and a lot of academics are, but with that comes a lot of things that, in fact, people living in low-income neighborhoods have been fighting for a really long time. I think there are solutions to this problem of displacement, so that I think you can have gentrification without displacement. In some cases, communities have talked about developing land trusts, where they buy up public land and have it as a trust so that it retains its affordability. It can be done through tighter rent controls. But I think really the key is that communities themselves should be involved in the process. They should have say-so over how to preserve that affordable housing, because they have a better sense of what their needs are than anybody else would.
For many of us, a goldfish was our first pet. Fun to watch, calm, low maintenance. What possible harm could a tiny goldfish cause? It happens every few years. Monster creatures from the deep stir up a media feeding frenzy.
Who did it? Who released their goldfish?
Some little kid who has gotten a little tired of their goldfish decides to release little Freddie into a local waterway to give it a future, not realizing the ecological harm that can cause.
We're at Flushing Meadows Corona Park with Queens College biology professor Dr. John Waldman.
Goldfish are in the news lately, partly out of an awareness that we have a country full of invasive species that are causing ecological harm, and goldfish are actually an ongoing threat too.
North Teller Lake has become a giant goldfish bowl.
A goldfish that's released at a small size into a lake can become quite large and can live for 20, 30 years and reproduce along that entire time. Goldfish change the ecology of a system in that they muddy the water as they root to the bottom. They eat a lot of the eggs of other fish. Goldfish in the wild are using the resources, whether it's food or oxygen or space, that other species could be using.
We have a lot of goldfish in this park, but they're not a huge problem because these are man-made lakes.
Yeah, these lakes are not natural in the sense that they were made for the World's Fairs. They took a natural estuarine creek and carved them up into two distinct freshwater lakes. These goldfish have sort of blended into the ecology of these lakes. Other parts of the U.S. are having a problem with goldfish in that they are invading lakes that don't have them already and changing the ecosystem.
In Carver County, Minnesota, officials removed an estimated 50,000 goldfish in one day.
In the case of goldfish, they're not, as with carp, they're not native to North America. They're not native to Minnesota.
Paul Moline is Carver County's planning and water management manager.
We had a couple capture events. They were in a small channel, and we were able to sort of walk the channel with nets and corral them into one spot and essentially physically pull them out with nets into bins in the back of a pickup truck. We put clove oil in with the water, and it essentially puts the fish to sleep before they die. There's a nearby compost facility that the county has an arrangement with, and we bring them to that compost facility, and they're turned into product that people can use.
50,000 goldfish in one day being taken is rather impressive. It makes me wonder how many were left behind if they caught that many in one day. I don't know how much of a difference it's going to make to the ecosystem, but it is one of the rare instances of people fighting back against an invasive species.
We're talking potentially 1 million fish, and we don't know if that's going to be feasible or sustainable. If we get rid of them, we want to make sure they're gone and not doing this every few years. We've tagged a bunch of these fish, several hundred, and we're tracking how they move. So they actually have little chips inside them, and we've got antennas that we can watch their travels, see how they migrate, see where they congregate. We need to know the best ways to remove them, and so we need to know where they are.
Releasing goldfish in a lake or waterway is illegal. Why not rehome Goldie to a school or pet shop? And there are many online forums dedicated to pet adoption, even goldfish.
Bottom line is, please don't release your pet goldfish or any other pets into the wilds.
We just eat our goldfish. What's that, Lassie? Timmy fell down the well? Can we really understand what dogs are thinking? I tell you, it's rough. Over at Hunter College, they're unraveling the mind of man's best friend. Here's Andrew Falzon.
According to the American Pet Products Association, there are about 89.7 million dogs living in the U.S. That means there are more dogs in the U.S. than there are people in Germany or the U.K. And we know a lot of interesting things about dogs. For example, did you know that like human fingerprints, dogs have a unique nose print, or that the shape of a dog's face reflects its lifespan? Longer face equals longer life. And the blood pressure of a human and a dog both go down when a person pets a pup. And for those who are on a never-ending quest to learn more about their canine companions, CUNY has just the place, the Thinking Dog Center at Hunter College.
Thinking Dog Center is a dog behavior and cognition research group. We're essentially interested in learning all about how dogs navigate the world around them, how they see the world, how they interpret it, how they interact with their owners.
Dr. Sarah Elizabeth Biozier is the director of the Thinking Dog Center and has spent most of her career focused on dog behavior. Some of her earliest research that's still ongoing today involves how dogs perceive visual illusions. It all started with postgrad research at La Trobe University in Bendigo, Australia. She was supposed to study service dogs, but that changed.
And we just sat down at a holiday barbecue one day, and we started wondering if dogs could see illusions. And what turned out to be sort of just this joke of a question that was asked at a barbecue ended up leading us to sort of start searching. We started off first by testing the Ebbinghaus-Titchener illusion in dogs. Once we discovered that, yes, there is in fact this field of animal illusions out there and people are studying them.
This is the Ebbinghaus-Titchener illusion. Which of those orange circles looks bigger? To most humans, the orange circle surrounded by the smaller blue circles looks to be bigger. But when you compare the two orange circles directly, turns out they're the same size. Turns out it's all a matter of our brains and perception.
It's actually very difficult to map perception. So if I ask you, for example, is a strawberry red? You will say yes. But the question is the red that I see the exact same color red that you see? It could be a different shade. It could be a little bit varied. It may be that they look identical, but how do we really know?
By studying how dogs perceive illusions like the Ebbinghaus-Titchener, it helps us understand how and why we perceive it the way we do.
And so one of the best ways to actually evaluate perception is to look at misperception, to see whether or not other animals also fall susceptible to sort of these like quick hacks.
So what were the results?
And so when we first started, we didn't really know. We were like, what are dogs going to do? We actually found that dogs were susceptible to the Ebbinghaus-Titchener illusion, but they demonstrated reverse susceptibility.
Reverse susceptibility means that dogs also fell for the illusion, but unlike humans who think this circle is bigger, dogs see this one as being bigger.
They're not alone in this reverse susceptibility. There are, in fact, other animals that do demonstrate this. And a lot of the time it comes down to how you process an entire figure. So do you process the whole, or do you process the individual components as being sort of singular units?
Compared to us, I guess our brains tend to group things together.
We tend to group things together. We are what we call sort of global processors. You know, I'm looking at this cabinet in front of me and I see a whole cabinet. I don't necessarily see the door handles and the doors and the drawers as separate entities. I see them as a cabinet.
Illusion perception is also being studied in other animals like reptiles and fish, and there are other animal illusion studies ahead for the Thinking Dog Center, some of which may involve cats. I'm Andrew Falzone for Simply Science.
Well, more good news. Flu season is here. And while we're still dealing with coronavirus, our Ari Goldberg climbs into his time machine to see how New York City dealt with the influenza pandemic of 1918.
Looking back through the records, there is plenty of information about how New York City at large dealt with the 1918-1919 Spanish flu. But we thought we'd look to our own university system, CUNY, as a microcosm for how the city approached the last pandemic.
At the time, CUNY was a very different place. There was no formal CUNY, in fact. But the College of the City of New York, what would be City College, was well established. And Hunter College existed too, but wasn't under the same umbrella. And of course, New York was a very different place as well. And consequently, so was the pandemic response. The U.S. Surgeon General had indeed recommended closing schools, and many cities did. But Royal S. Copeland, the head of the New York City Health Department, decided to keep them open. He argued, "I don't know their conditions, but I do know the conditions in New York, and I know that in our city, one of the most important methods of disease control is the public school system." The thinking, right or wrong, was that it was actually more dangerous to keep students at home in the crowded tenement buildings of the time than it was to have them at school. And so, City College remained open. And surprisingly, it would seem that life on campus actually went on more or less as normal. In fact, there are only a handful of references to the pandemic from the school records of the day. The Board of Trustees did delay the start of some courses for 3 months, citing influenza. But this was also as much to accommodate soldiers returning from World War I as anything. And there are also articles in the City College campus paper about closing the pool as a precaution, and about the school infirmary doing a good job keeping a handle on things. Particularly interesting, though, as a window into life on campus at the time, is seeing the rest of those papers. Those very same editions of the paper are actually still advertising student events and social gatherings, business as usual. In fact, the very same article about closing the pool is also promoting vaudeville shows, music programs, and, a mere subway ride away off campus, a night of supper, entertainment, and dancing at a certain Hunter College. Quite the opposite of social distancing. Now, that is not to say City College wasn't affected by the Spanish flu at all. The whole world was. Mask wearing and business closing was implemented much like today, and New York City as a whole would lose 33,000 lives, though it did fare better than several other American cities. But by and large, it does imply CUNY weathered the storm rather well, and stands as a fascinating snapshot into the mindset on campus at a similar time of crisis.
For Simply Science, I'm Ari Goldberg.
And that's our show. As always, you can find us online at tv.cuny.edu, YouTube, Facebook, and Instagram. I'm Barry Mitchell. Stay safe. We need the viewers. See you next time on Simply Science.